Welcome. Today, I will share how a multi-agent society was implemented to detect anomalies in the financial markets. We'll also talk about how the system can be generalized to implement it to other types of problems and share some of the existing challenges with the technology, as well as some possible solutions. So the paper this video is based, is enhancing anomaly detection in financial markets by the International Bank of Settlements in Basel, Switzerland. What they distinguished was that there were important benefits in automating many of the tasks involved in detecting anomalies. For example, the thresholds need to be lower on the supervised models, and a lot of manual investigation needs to be carried out to distinguish false positives from true positives. So one of the benefits of using multi-agents in this type of problems is this is a complex problem that requires specialized skills. We will see some of them in the next slide, but they involve researching, they involve data analysis, they involve normative law, etc. Another benefit of using multi-agents for these particular problems is that a decision needs to be made. And there are multiple ways to approach this decision. And one has to evaluate the risks and the costs of making each action. So having a diverse perspective from different set of agents helps arriving to the best decision. So the agent society they proposed starts with the supervised models that detect anomalies and ends with the human at the end making the final decision if necessary. And it has three main components in the middle. First is the data analysts. The data analysts have different skills like surfacing the web or doing cross-validating information, and they take the information from the anomaly detections and supplement it based either on historical events or based on even the results itself might require some diving deep. The second set of groups that is in blue are the managers. And they discuss, once they receive the information from the analysis, they discuss possible solutions or actions for the problem. They decide if this is an anomaly or not. They use different set of views and they pass the information to the human. Or maybe even choose an automated action. And the final decision and the final agent, very importantly, is the critical thinker. The critical thinker acts between steps, moving from supervised analysis to data analysis. First, preparing the results so that data analysts can use it. Second, summarizing the findings between the data analysts and pass them to the managers. And similarly, creating a report of recommendations from the managers to the humans. That is how the agent society is composed. But everything is not perfect. We have communication problems. First, it's costly, calling so many large language models, and also it's slow. There's ideally we want to act very fast to prevent fraud, especially in if it's the type of real time, because otherwise the damage can be increased. But this problem, the discussion between the managers, the analysis of the data analysts is slow, and even worse is sequential. So this could be a decision made, yes, maybe it's automated, but may still take 10, 15, 20 minutes, which is far from ideal. The second problem is that there is no metric or benchmark to validate the validity of the arguments and the summaries. So the managers are discussing, are emitting their opinions, but what makes it right or wrong? How can we improve it? How can we know who to listen? And also, the summarizer might miss some important information from the data analyst or may not have communicated to the human an important point. So there's, again, no validation in the quality of the summaries. And finally, is that there is no learning in the system. Just as it's set in the initial phase, it stays pervasive. And we might require that the data analysts develop new skills. We might need to adapt the model for changes in threats, and we also might need to adapt the personalities of the managers to improve, to reward the most effective ones. So those are some of the challenges. And we will talk about, and here is an example of the amount of communication this goes, either from the data analysts, the managers, the reports. It's a lot of written. Even if it automates part of the work, it still creates a lot of paperwork. So the solution is not ideal. And I will talk about some potential solutions at the end of the video. But first, I want to start generalizing this framework about how to use this society for different types of programs. And it has, again, we saw it, 3 components. First, skill-based agents that perform specific actions, either based on API or symbolic programming. The second is managers that discuss potential actions for decision-making. And finally is the critical thinker that moves the process forward. So how would we apply this for financial predictions? First, we could have in the realm of data analyst, a financial sentiment statements analyst. So this, the agent would research key changes in the environment or compute different financial ratios and use those financial ratios to estimate the likelihood of a stock going up or down. Second, we will have a market researcher. It will be noticing news about the competition, estimating demand, reading news about the companies, developments in technologies. It will be mostly on the news. And finally, we could have a macroeconomic point of view. Maybe at the manager, maybe at the data analyst, maybe at both. But we could have how changes in interest rates, in the growth of the economy, in international trade relationships, how would that affect this particular company? And once having those analyses, we can start the discussion of whether a stock will be a buy, a hold, or a sell. That's just one example. I hope especially that the general framework was clear. Now, moving towards some of the problems that we started seeing, how would we allow the development of agents? And here is meta development of agents developing agents. So it starts all with reflection, which I already have a video and I recommend watching. That in this reflection algorithm, we start with we distinguish what is right from wrong. What is if a given decision was right, why was it right? Or if a given decision was wrong, why it was wrong? And we start to have this critical thinking, not only a priori, but also a posteriori, after seeing the results. Once we have this knowledge about our performance, we can start developing evolutionary learning, maybe in parallel, maybe feed from the reflection. And what this does is that it requires the best agents. So let's say, for example, that a given discussion between managers, one of the managers had 40% of the time. And if the decision was accurate, then we will reward this agent to talk more. If the decision was wrong, then we will disencourage the agent to talk less. And we might even eventually deprecate that particular agent. And similarly, we may want to create different agents based on the better performing ones. Similarly, if during the reflection process we detect some needs, we can start iterating through prompts to find the best agents. And similarly, we can also iterate existing agents, trying out different variations of prompt. So that is evolutionary learning, and that's a very interesting area of research and application in developing agents. And finally, the RAG and web data. So right now our system is endogenous, meaning that it only considers internal information for their decision making. besides the one that's implemented from the supervised learning. But what will happen if we can develop new skills by learning on the web? So let's say we have a statistical analyst, and we learn that there's a new library, a new analysis method, and it can start trying it out. Similarly, managers, if we start to see that there's some financial analyst that's having good performance, we can learn by imitation. We can acquire new skills entirely completely. If we don't have financial sentiment, for example, in this particular model, let's assume that we are detecting anomalies. Maybe we detect that social network sentiment analysis would benefit, and we could create some sort based on. So that would be another way to develop agents, incorporating information from the outside, exogenous. Now, a second problem that I want to begin sharing a solution, thinking about the solution. And how do we regulate or moderate the communication between agents? Are we just assigning the word randomly, or are we actually have a mathematical process that rewards agents that have something good to say? And here I will draw inspiration from the neurotransmitters. So what ChatGPT noticed accurately is that the brain is composed of multiple parts, each with a given specific function, just as an agent society. And how are these different parts regulated? Through neurotransmitters. And that facilitates that a particular part of the brain has more prominence for specific situations. Some examples of neurotransmitters include dopamine, that helps estimate that helps create motivation to pursue future rewards. Serotonin, that prioritizes focusing, reasoning, thinking before acting. Endorphins, that mitigate pain and create pleasure, for example, when exercising. And orexin, that also creates motivation. So this type of neurotransmitter regulate the communication in our brain. So we could start, for example, if we are thinking, if we are sensing that the discussion is not having enough deep dive, we can give a specific agent the word. If we are not thinking practically, or if we are not seeing something, we might be either asking someone with a lot of experience or someone very creative. And in that sense, we can start orchestrating the agents based on this discourse, based on how the conversation is progressing. Now, reinforcement learning. This is key. What would happen if and that could be a way to implement this. Finally, I want to end this video. Thank you for staying until now, to share some interesting ideas that I didn't cover but might be applicable. The first is, what are the characteristics of the problem that maximize the effectiveness of implementing a multi-agent system? I mentioned a couple, that the system would benefit from diverse skills and diverse perspectives, also ideal for decision making. Are these the primary characteristics of the problem that reward an agent, or are there others? I would like to hear from you in the comments. Second, are there scenarios where multi-agents do not benefit from using a shared memory? There are, for example, cases in deep reinforcement learning, for example, in self-driving, that all the agents have the same training procedure. And that's a benefit. There are also theories about communication where the best scenario is that the communication is fully transparent, that everyone is communicating with everyone else. And one would think that the same happened with memory, but I here want to pose a question. And one scenario that I see, for example, is if by restricting information, I can inspire creativity in agents. So some of those scenarios are interesting, and even the wider topic of shared memory is very interesting. And finally, how the concept of signal processing frequencies be applied to enable simultaneous communication among agents. And this is very similar to the agent orchestration, So the idea would be, okay, there's one agent talking, but that doesn't mean that the other agents cannot exchange information between each other, just as we humans do by non-verbal cues. And the idea would be to have certain frequency space where each agent can communicate with each other. And that communication is not necessarily verbal, but numerical. For example, if we are seeing that one particular manager is thinking too deeply and losing the big picture, is going too deep in the details, we can emit a particular numerical signal that communicates just precisely that idea between two agents. And maybe if there's agreement in that idea, that can be dispersed to the other agents. And if this communication happens, then it can be verbalized to start using reasoning process. Okay, we detected this need. How do we implement it? So that was all. I hope the video was good for you. I hope you liked it. Please let me know in the comments. Please support the channel, either a like, either a subscription, my first subscription. I would love to hear from you, and thank you. Thank you so much for watching to the end. Goodbye.